This is Dr. Brown. In this video, we're going to continue in the data analysis unit, and we're going to talk about how we measure the center of the data and the variation in the data. This is in pages 262 to 270 in your textbook. Before we actually go through definitions and everything, I'm just going to show you some data on things you've probably heard of in your experience. Suppose we looked at the height of adult women and adult men. Obviously, you know that all women are not the same height and all men are not the same height. And what you would see would be a distribution similar to what you see here. For instance, for adult women, the mean or the sort of the midpoint would be about 5'3" or about 162 centimeters. But notice there's a large variation. You will see some that will get up to 180 centimeters and some as short as 140 centimeters. With men, you see similar kinds of data, but you see a median or midpoint of about 175 centimeters, which is somewhere between 5.5 and 6 feet. And then, of course, you see some men who are very tall. The next chart is sort of a smooth rendition of the data you just saw. I'm not exactly sure whether this is for any particular country or for the world or what, but it's just something I got off the internet. And here you see a similar kind of thing, maybe a central or average of 65 inches for women and about 72 inches for men. If all women were a lot closer to the average, you might see a curve like this, a very small variation for women. And if men were a lot more like the average with very little variation, you might see a very narrow curve for the variation of the height of men. Now, if everybody were the same height for women, you would just see a chart that had just a simple spike, an arrow at what everybody's height was, and be the same thing for men. Here, the variation would equal 0. Of course, not everybody's the same. In fact, just about any data you can think of, not everybody is the same. Here's a curve you've probably seen of, say, exam scores. This could be a typical exam in which the mean or average would be about 75 on the exam, with some going up to the high 90s and some as low as 54. And we're going to not get into right this very second all the details of this chart, but this gives you an idea that data can vary and we need to measure the variation. So let's look at some definitions. Let's talk about the measure of central or center tendency. We could talk about the distribution of a variable or a data set, and this refers to the way its values are spread over all possible values. A distribution can be shown visually with a table or a graph. Now, here is one um, variable that I'm sure you've heard about. It's the mean. Um, the arithmetic mean is what we most commonly call the average, and you just simply sum up all the values and divide by the total number of values. Now, the median is a middle value when the data set is sorted in numerical order, or it's halfway between the two middle values if the number of values is even. I'm going to show you just a simple example. Suppose we had 2, 3, 4, 5, 6 numbers. These are I'll say 5 numbers in the data set. The median would be 4. If the numbers were 2, 3, 3, 4, 5, 6, the two middle numbers, which are 3 and 4, the median would be 3 plus 4 divided by 2 equals 3.5. So what you do is you sort out the data in order and take the middle value if it's an odd number of data points, and take the average of the two middle ones if it's an even number of data points. Now, the mode is the most common value or group of values in a distribution. If I had 2, 3, 4, 5, 5, 5, 6, 10, 12, suppose these were the numbers, the mode would be 5. If there is not a number that has more instances than any other, then the mode does not exist. In other words, if you had 2, 3, 4, 5, 6, 7, you have no mode. An outlier is a data value that's much higher or much lower than almost all other values. The outliers almost always affect the mean of the data set. For instance, suppose we had the heights of men, say, in town, and they were like 5, 5.5, 5.6, 6.0, and then you had someone, I'm not sure what the tallest person could be in the world, but maybe like an 8-foot person. This would be an outlier. All the others are close to maybe an average of 5.5. This is an outlier, and it can really affect the data. We'll see another example. Suppose everybody in a group had a salary of, say, close to $40,000 a year, and then you had one person who made $5 million a year. That person would be an outlier. Now, the range is very easy to calculate, and it's just the difference between the maximum value and the minimum value of the data set. So if you had 2, 3, 5, 8, 22, this is a min, this is the max, and the range is 22 minus 2 equals 20. Now the standard deviation is a value that we're going to be calculating quite a bit. In fact, you will discover that this is a number you want to calculate generally with your calculator. And this is where you want to have your TI 30XS available. We'll do it by hand, and we'll then show how you absolutely got to do it to get an answer that's reliable, because it's so easy if you're doing things by hand to make a mistake. But the standard deviation is a measure of the variation based on measuring how far each data value deviates from the mean. Standard deviation has these characteristics. It's always positive. Standard deviation will be 0 if all the data values are equal. In other words, if all men had heights of 6 feet and with no variation, then the standard deviation would be 0. And the standard deviation gets larger as the data spreads out. And the standard deviation has the same units as the original data. And the standard deviation can be highly influenced by these outliers that we've talked about. Now here is how you calculate the standard deviation. It's pretty simple to see, but when you've got a lot of data points, it can get pretty complicated actually calculating it. But the standard deviation is equal to the square root of the sum of all the deviations from the mean squared divided by n minus 1. The total number of data values minus 1. So you take each data point, subtract the mean, square it, and do that for every data point, add them all up, and divide by n minus 1, and take the square root. Now this is a shorthand notation here for what I just said. This Greek symbol sigma is called sigma, and it's the summation of all of these values. X of I is an individual data value. And of course, X bar is what we call the mean. So you need to get familiar with this notation. And S, or sometimes you'll see it on your calculator, S of X, is called the standard deviation. Now let's do some examples. And we've got a following data set of t-shirts. How many are sold per week by a student who started his own online t-shirt business? We want to find the mean, median, and mode. And we're also going to calculate the standard deviation. But here is a chart. The number of times that 3 t-shirts were sold per week were 5 times. The number of times 6 t-shirts were sold was 2 times. The number of times that 9 were sold was just 1 time. And interesting, the number of times that 12 t-shirts were sold were 4 times. So let's write this data down, notice we've got 5 3s. I'm doing this in order. We've got 2 6s. We got 1 9, and then we have 4 12s. So let's look at this data. The first thing you can do is find that the 2 center numbers are 6. So the median is going to be 6 plus 6 divided by 2 equals 6. It's pretty obvious that the maximum is 12 and the minimum is 3. So the range is 12 minus 3 equal 9. And then the mode, just taking a glance at this, the mode is going to be 3 because there are 5 3s. If you have a chart like this, you just need to look at the highest frequency, and that tells you what the mode is. Sometimes you will not have a mode. Okay, to calculate the mean and standard deviation, we will again lay out the data. And the mean is pretty easy to calculate if you put it in your calculator correctly. You put in your 5 3s, your 2 6s, your 9, and 4 12s, and divide it by the number of data points, which is 12, and you'll get that the mean is 7. Now, the standard deviation takes a little more punching into the calculator, but it's going to be the square root of the summation of each data point minus the mean squared, add them all up, divide by 11. If you did it this way, be sure you put in 3 minus 7, 3 minus 7, 3 minus 7, 3 minus 7, 3 minus 7 squared 5 times, or you could have put it in as 5 times 3 minus 7 squared in your calculator. We'll take it, but save you a little bit of time. But this is just laying it out, showing you how you could do it. You got your 6 minus 7, and your 6 minus 7 twice, or 6. For the 9 data point, you have 9 minus 7 just once. And then finally, you have 12 minus 7, 12 minus 7, 12 minus 7. 12 minus 7 squared 4 times. And all of that is in brackets. And you then divide by 11, which is n minus 1, and you calculate 4.11. What I'm going to do is show you how to do this in your calculator. I'm going to bring up the calculator, and I'm going to put all the data in. You bring up your calculator and you hit data. And notice we have at least 3 data sets we can put in the calculator. L1 is the first one that comes up. And notice that L1 at 1 has nothing in it. So I am going to very carefully put this data in the calculator. I'm going to put 3, down arrow 3, down arrow 3, down arrow 3, down arrow 3. Now I've got 6, 6, 9, and now we got to put 12 in 4 times, 12, 12, 12, 12, and that should give us 1, 2, 3, 4, 12. So now we've got the data in the calculator. What I would do is go back and check your data. L1 at 1 is 3, 3, 3, 3, so forth and so on. I'm going to assume I got this in correctly, or got this in correctly. Now that we've got the data in, we're going to do second stat, and we want to do one variable statistic, so we hit enter. It wants to know which of the data sets we want to look at. Be careful here and pick L1, and then frequency is going to be 1, and then we hit calculate. And notice we have X bar equals 7, the mean, which we just calculated. And the standard deviation is 4.11, which we said it was. And you go through here, and you see some other numbers here, like the summation of the X squared. We got the minimum value was 3. We got the first quartile, which we'll talk about later, is 3. The median is 6. The third quartile is 12, and the maximum is 12. So all of this gives us the information we need on the range. Notice the maximum is 12. And the minimum is 3. So the range is 9. So now we can summarize the data on this data set. The mean is 7, the median is 6, the mode was 3, the range was 9, and the standard deviation was 4.11. Now we're going to do another example. For this data set, we have just 5 data points. And these are contract offers. And we want to find the mean, median, mode, range, and standard deviation. I don't know whether this is a contract for salary or contract for doing something, or whatever it is. We want to calculate the mean, median, mode, range, and standard deviation. And so the data is 50,000, 80,000, 100,000, 90,000, 10 million. We want to put in ascending order. Notice there are 5 values. Putting them in ascending order, we get this. And now we can calculate the mean. It's just summing them up: 50,000, 80,000, 90,000, 100,000, 10 million divided by 5. The mean is $2,064,000. The range is the largest, which is 10 million minus 50,000, which is 9,950,000. That's a very large range because, folks, we have a big outlier here. Now, the other thing I wanted to point out was, after we got in order, the median is 90,000 because it is right there in the center. Now we're going to calculate the standard deviation. Now, basically, you take each value, subtract off the mean, which was 2,064,000, square it, and do this for each data point. And I won't go in show you how to do this individually on the calculator because we're going to put this data in the calculator and show that we can get the same thing much easier. If you add all these up, you get 7.87 times 10 to the 13th. The sum divided by 4 is equal to 1.968 times 10 to the 13th. And if you take the square root of that, you get the standard deviation is 4.436 million. Now, I'm going to now put this in the calculator. And after this, I'm just going to let you put things in the calculator. I'm going to go in and hit data. And I'm going to put this in L2. So I'm going to put 50,000. I'm going to put 80,000. I'm going to put 100,000. I'm going to put 90,000. And just be careful with everything you put in. Now I'm going to put the 10 million. Make sure you got the right number of zeros or you're going to get way off on your calculation. So I would go through here and look at the data. There is 10 million, 90,000, 100,000, 80,000, and 50,000. And now we're going to calculate the data on the calculator, and we're going to hit second stat, and we're going to do one variable statistics. Hit enter. Now we're going to tell it what data set we're going to be using. And we're going to use the data set L2. So hit enter. And frequency is going to be 1. And we go and now hit calculate. And now notice, always check your N. The N is 5, which is what we knew. The mean is $2,064,000, which is what we had done if we had done it by hand. Standard deviation is 4.43639.831 to the nearest cent. And it will tell you the median, which is 90,000. We already knew that. And of course, the maximum is 10 million. So we get all of this data on the calculator. And this is the way I recommend you do this, folks. Now, we're going to have one more example. We've got the following data set of gallons of gasoline purchased by drivers, by 28 drivers. Find mean, median, and mode. Here is the data. And here is the data sorted. And if you did it by hand, you can immediately see that the median is going to be 7 because the two center points are 7 and 7. So the median is 7 plus 7 divided by 2. The mode is 4 because you see 5 fours. And there's no other number that is as high as it is represented more than 5 times. And the range is 18 minus 2, which is a maximum minus a minimum. I like to tell you to check your work, input the numbers, and then check them. Now, we could do the standard deviation by hand, but I recommend that you put this in your calculator. Now, to calculate the mean and the standard deviation of this data, I'm going to go to my calculator where I have already entered the data. I'm going to go to data. Oh, by the way, if you wanted to clear any of the data, you just hit clear. But I'm going to go to L3 data set. Notice I've got L3. The first one is 7. Second one is 4, 18, and so forth and so on. I have put all of that data in the calculator all the way down to 3. And now we're going to calculate the statistics on that. Hit second data, which is statistics. We hit variable statistics. And now you pick the data, and the data is coming from L3. You hit enter, and then you go to frequency, and we pick 1. And now we notice we have 28 data points. The mean is 7.5357, and the standard deviation is 4.10. So now we have all the data points. The mean is 7.54. You recall the median had been 7, and the mode was 4, and the range was 16, and the standard deviation is 4.10. Now, the last item we're going to cover is to look at how do we treat categorical data. Suppose we had the following data set of vehicle colors. We had 3 blue ones, 5 green ones, 3 gray ones, and so forth and so on. Notice there is no mean for the color. There's no median for the color. However, there is a mode because it turns out there are 5 green ones and there's no other color that's used that's higher than that. And the standard deviation is none and the range is none. So it's a little bit easier to do these calculations for categorical data. Anyway, that is a section on measure of center and variation.